So we're going to be dealing with right-angled trigonometry in this course. That is, we're going to only focus on right-angled triangles and methods for solving those. Although you can use more general methods like the sine and cosine law as well. When people see Pythagorean theorem coming into this course, like as a title for a chapter, sometimes they might think, oh my God, this is going to be so easy. I'm just going to do like Pythagorean theorem and it's like whatever. I just do some a squared plus b squared equals c squared and we're done. And for the most part, that is true for the easy questions, but you're going to quickly see that this theorem can be used for some very complicated situations. So although in this chapter, we're just dealing with more simple cases, in chapters 5 and 6, we're going to be doing increasingly more difficult trigonometry questions. As you know, in the course tab on Blackboard, I have put the entire set of notes for this course there. This way, if any student wants to work ahead, they can do that. And in those notes, there's chapter 6. So if you want to see some harder questions, wait till you get to chapter 6, and then you can at least have some practice and build up your confidence. But today, it's about building up confidence for those that may have not seen this for a long time. So that's what I'm going to do today. I'm going to spend the lesson today reviewing the Pythagorean theorem, this thing right here, a squared plus b squared equals c squared. And we're going to do a lot of questions. We're going to do them carefully and hopefully build up that confidence. As you can see, the notes here are a little bit more typed up and clean. These notes, I had the opportunity at some point recently to just type them up and clean them up because I figured the trigonometry was probably the most important notes that needed to be revised. So hopefully there's no typos. If you find a typo, please email me so I can update any revisions. These example boxes here, they are fully solved, and you can go through them and tells you how to do things on your calculator. So up to page, we'll go here, up to page 4, there are 2 examples that I'd like you to review on your own. I'm not skipping them because I don't want to show them to you. I'm skipping them because the answers are right there for you to read. So what I want to do instead is actually just answer new questions with you that are equal, at least, if not more difficult, eventually today than these questions. So let's start off by going to examples on page 5. So please turn to page 5. If you don't have the book, that's okay. And what you're going to see is that this presentation, the questions are missing. So this PowerPoint presentation, what I've done is taken screenshots of various questions from the booklet. So if you see a page number here, it's legit, it's consistent with your notes. But if you see the blankness here, it's because I deliberately have cut out some stuff. So let's take a look, and we're going to solve 2 questions together right now. I'll circle the ones I want you to try. So let's take a look here. We're going to do this one here. I'll call this question, well, I'll call it Roman numeral number 1. Never mind. I'll just check mark it in green. Let's use check marks. And I'll do this one in purple, okay? This one here, we're not going to do it. Don't worry about it. I sampled a bunch of questions. I didn't really decide which ones I'm going to do or not do. I'm just going to go with the flow and see what you guys say. The first thing that I want you to notice here is that, do you see ABC in this picture? Do you see ABC in this picture? Does it have the variables? But does it explicitly say AB? Is this A here? Like, no, right? So what I want you to do is the following. I don't want you to use this formula. A squared plus, I don't want you to use A squared plus B squared. I know. Leo, I will explain in a second. No. You don't understand what I'm saying yet because I haven't written it down. But I promise you, I will explain briefly. What I'm saying is, If I use this formula, I have to go and relabel the picture. Do you see what I'm saying? I have to go and I have to call this X here. I have to call it C. So it's like I'm doing extra work. I have to call this C now, like, but it's called X, right? Like, why would I want to call it C? That's what I'm trying to say. So instead of writing A, B, and C, what I'm trying to say is don't use those letters. Use the variables in the picture. Instead of writing that, use the variables in the picture. So in this picture here, which one is the longest side? Can you tell me? 3, 4x. Thank you. So I'm going to delete that because I want you to get used to this. You're going to get used to me not writing ABC. So x is the longest side. All you have to remember is that the longest side goes by itself. Can you remember that? Longest side by itself. If you remember that, then you can answer the question over here as well. Longest side by itself. What's the longest side on this picture over here? Thank you, Malik. What's your question? What's your question? I'm waiting, Leo. Let me know. Sorry, just waiting on the chat. Okay, you say the longest side, but how do we know if we don't know x? That's a very fair question. So the answer to the question is, how do you know that this side is the longest side? Who can answer that question in the chat? How do I know that this side is the longest side? Okay, the side opposite which angle, Shalon? That's your on point. Which angle? Thank you. So to answer the question, the longest side is always opposite the 90-degree angle. That's good. No, I'm glad that you asked that. I'm glad that you asked that. So opposite the right angle. Beautiful. So you know what? It's a very important comment. So I'm going to say that over here. I'll say it right here. I'll do some manufacturing in a second. Longest side, which is called the hypotenuse, is opposite the right angle. Okay, good point. So I kind of might have scared you there in the beginning when I said to you, I'm not going to use the formula a squared plus b squared equals c squared. A few of you got rattled right off the bat, and I always do that. I want to shock you. I want to shock you in that first minute into remembering that ABC is not useful if there's no picture that has ABC on it. You want to use the quantities in the picture as close as possible so that you don't start renaming things. Now, in this case, if the longest side is the variable, then this type of algebra is not that bad. So here we have 9 plus 16 equals x squared, 25 equals x squared, or x squared equals 25, or x equals 5. If you want to see an extra step there, I'll definitely put the square root of 25. And we're good. Any questions about this answer here? Let me know in the chat. Who's feeling okay with what I did there? Let me see. Thank you, Denny. I want to see about 10 people say it before I move on. Okay. Yes, sir. I want someone to type in the chat adequate. Give me the least complimentary answer is adequate or satisfactory. Thanks, Daniel. How was your teacher this semester? He was meh. He was meh. Sufficient. Okay. Stop picking on me now. I feel kind of sad. Okay, let's move on. All right. Okay. All right. And anyway, In this question here, the longest side is z. Sorry, the longest side is 8, but the variable z here, it has to be isolated. So before, you know BEDMAS, think of BEDMAS, right? You know BEDMAS? So E is first. See exponents? Do the exponents first. So in this case, you have 9 plus z squared equals 64. And just move the 9 over. So eventually, I got here, I don't have my calculator with me. I'm relying on you guys to give me some support there. So what's the square root of 55? 7.4 something? Is that right? Thank you. Oh, sorry, 3 decimal places. Yeah, so 416. Thank you, Denny. And the units are meters. Back over here, as per Shalon's comment earlier, we're going to put here 5. We don't. It says you're accurate to 3 decimal places, but it's 5 exactly. So you don't have to write 5.000 or whatever, okay? You only have to write it if you need to write it. There we go. So I want to show you a more economical way of answering the same 2 questions. I know that I'm kind of going extra on the easy stuff, but it's this investment that we make here that makes life easier later, okay? So I'm going to go back here, and I'm just going to make another comment. Shortcut. That's right. Getting to the answer without the extra workings there. So what I'm trying to say here is if you want to save yourself some writing, you can do the shortcut, which I'll highlight in green. Malika, I'll talk to you about that during the break. I don't remember at this point, but I gave you the credit for it, so don't worry. I did see the email. I think I got an email from you. We talked about that 3 days ago, though. So it's been 3 days. A lot has happened in 3 days. Okay. I gave you credit for the question, so don't worry about it, okay? So if the variable is the hypotenuse, you put a plus sign. See the plus sign right here? And if the variable is not the hypotenuse, you put a minus sign, which brings the question, which one goes first? Because over here there's 2 numbers. Do I do 8 squared minus 3 squared, or do I do 3 squared minus 8 squared? Can someone in the chat let me know, why don't I worry about that? Why is this not really an issue about which one goes first? Why is it easy to figure out which one to put first? Let me know in the chat. Why is it easy to figure out which one of these 2 numbers has to go first? Yeah, it is the bigger one. But why is it the bigger one, Daniel? Yeah, that's right. Read Daniel's answer in the chat. Because you can't take a square root of a negative. You get a math error. Yes. I like Ram's comment as well. So let's move on and do some questions. In the beginning, everybody, I promise you, we are just like reviewing this from scratch. I'll do it like this, but I might cut out maybe 1 or 2 lines of writing. And then as we get smarter and stronger, we're gonna, as we get smarter and stronger with this stuff, we're gonna do this, okay? We're gonna cut out the extra step. So here's your opportunity to practice. So I want you to solve here and see the variables A, B, C. A, B, C is just variables in a picture. See, like here we have letter C, but C is not the longest side. So that's why it's another reason that you shouldn't use the formula just oblivious to what it means. So we're going to do this one over here. And I'll do the one over here just for space. Actually, we'll do this one right here. We'll do these 2, okay? We're not going to do the one over here. I'm being strategic, as you know. I'm not lazy. I'm just trying to be very strategic with what I do with you. Because this one here is like the first one. So that's why it's like doing the same thing twice. So in this question here, in this first question, and this lesson's recorded, so obviously you can review it later. Which is the longest side on this triangle? Yeah, the 10, right? So the 10.44 has to go by itself. So let's do that. A squared plus 7.85 squared equals 10.44 squared. So the first thing you want to do is the exponents. So I'm relying on you for that. But before I do the exponents, I'm gonna actually just move the 7.85 over. I think it's a little bit cheaper this way. That's what I mean about compromising and cutting out a few of the steps. So can someone type all that stuff on the right-hand side there? Anybody have that on the right-hand side? That's the final answer. I just wanted this piece. 43, 7, 3, 11, right? Thank you. See, I got it here. Thank you, George. And then that's equal to, so we have here, what, 6.88? Sounds good? Yeah, that's good. I got 6.88 as well. Okay, let's do this one over here. I said I didn't bring a calculator with me. I didn't say that I wouldn't use the internet. Okay, what's the longest side on this triangle? What's the longest side here, right? Now, I'm gonna go with this. 4.605 squared plus 5.228 squared equals b squared. This is how you would write it, with the conventional Pythagorean. However, I want to put the variable on this side. There's nothing wrong with what you're writing. It's just this way. I like to read it this way. I still have the longest side by itself. I like to read it that way. So I'm gonna take this stuff over here. Go to my friend Wolfram. Who knows this website, Wolfram? It's a visual advantage, Shalon. That's all. It's just a visual advantage. It's just because you're reading it backwards otherwise. That's all. Yeah, take a screenshot of this site. I'll put in the notes here. Hang on. I took a screenshot, but it disappeared. Yeah, I got the same. I got a 7 at the end. I'm just checking my answer key. So you see, yeah, this site does everything, Shalon. It does everything. I mean, not everything, but if it's something like formula based or mathematical based, like take a look here, okay? What is the pressure of our atmosphere? Not really. No, there's a pro version that does. See, it tells you like whatever you want, right? What is what is love? Hey, look at that. What is love? Actually, it's kind of cool. It'll do anything. It'll do anything. Like anything that's like it uses artificial intelligence and it just kind of figures out what it wants to what you're asking. It's like it's like a math Google at the same time, Anyway, so we got that answer. This is not pretty. That should be inches. And this one over here should be centimeters. And oh yeah, comment for Ram. Ram's answer and my answer differed by one number here at the end. So you see how Ram had a 6 and I had a 7? If your answer is up or down by one digit, it's okay. So what I'm saying is, if you get 6.966 or 6.968, it's okay. Don't worry. But if you get, for example, 6.978, that's way too much. It's too far. So you wanna be reasonable within your accuracy. So usually up or down by 1 digit at the end, I'm good. And of course, don't forget the units. That's just lazy on my part to forget them. So how do you feel about this introduction? Is some of this coming back to you? Hopefully. Okay, I'm glad. Let's do another question together. And thank you, Ricardo. I'm gonna do another lesson with you now. Another question, sorry, not another lesson. We're gonna be here for a while. Let's do this one here. So we got this compound figure. So I'm gonna just label two triangles here. I'm gonna call this triangle number 1, and I'll call this triangle number 2. So let's take a look at triangle number 1. We want to solve for P and Q. So from triangle number 1, what's the longest side on triangle number 1? Which of these values? Yeah, the 2.755. Thank you. And you see, if you just ask yourself what's the longest side, shockingly, you're not going to write ABCs anymore. I said that to you at the beginning of class, and I know some people were getting rattled. But now in hindsight, do you see why I said I don't care about ABC? Good. Because I don't care about A, B, and C. You could file a complaint and say that your professor does not like ABC. He needs to be a little bit more friendly to ABC. Which I'll reply, I don't care about ABC, respectfully. Notice that I put here the 1.230, I moved it over so that I can take all this stuff here, and you can do it as well because your calculator understands bedmass. Bedmass, your calculator knows what that means. So, whoops, I'm on my other desktop. That's not cool. I'll catch up to you. Keep on typing your comments. I got this. Did I copy the question right? I think so. Oh, yeah. Thank you, Daniel. Whoops. Answer? Is it 2.46? Is that what we're working with? I'm trying to find it on my sheet here. Okay. Well, let's put extra. I need more. I need extra digits, friends. I'll put 2.465. What's the longest side on triangle number 2? What's the longest side? Yeah, it's P. It's P, that's right. So Q squared plus 1.158. And now I'm going to do a lol. You know what the lol is here? The lol is, yes. Shalon, focus on what the question says, not anything else really, because the question will tell you, okay? So the question here says 3 decimals. Now, in reality, you should use extra decimals. So over here I have P squared. I'm actually going to put this number in because it's P squared anyway. Might as well, right? That's why I said LOL here. Because I'm going to just use this number instead. Instead of plugging in this number and squaring it, which seems kind of backwards, why not put this number, which is exact, or not exact, but more accurate? So that's what I did there. And now it's a matter of just, whoops. The nice thing about copy and paste here is that I can write extra steps. Because if I'm doing this on the board, it gets very, very, very slow. Yeah. So I figured the trade-off is I can copy and paste it. I might as well write a few extra steps. It doesn't slow us down, and you get like the full story. Someone give me Q to 3 decimals, please. There. Now I feel like a professional. 2.176. We have confirmation. Thank you, my friends. If you're wondering, I do know how to type, but for some reason there's like a lag time. Perhaps I'm running too many things at the on the computer. So what do you guys think? How do you feel about the stuff we're doing? Is it a little bit more interesting than what's the angle? I promise you, you're gonna get some really nasty questions in chapter 6, but that's why we're going nice and slow here, and it'll be very entertaining as we move on and move ahead to bigger and better things. No, yeah, okay, you know what makes these questions easy? I'm glad that you like the shortcut. What makes these questions easier is that you have a picture and you have the triangle. So I'll just say that here, just so you get that in your mind, okay? Easy question equals, maybe not equals, triangle is given. Tougher question, triangle is not given. That's basically it. It could be triangle or triangulus. Let's do that here. Point is that we're going to do some more questions and get you up to speed and make you feel nice and strong. Yes, those examples are not in this section yet. So those examples that are not as easy, they are going to be what we focus on next week. But I'll try to give you an introduction today to that. So let's do this question. I like this one. Is this a right angle triangle? Are you talking? Sorry, Denny. Denny's question. Are you talking about this, Denny? Oh, I'll go look back at the assignment. I don't remember it. I can't solve the assignment question when it's not even due yet. Oh, yeah. Here, let's do this question, guys. Let's move on. Yeah, it's two right angle triangles. I'll give you insight into the assignment, but for now, let's focus on the lecture, guys. So in this case, we want to find the area of the triangle. Find the area. What's the area of a triangle? Anybody? Well, it's right here, actually. Never mind. At least I was nice enough to give it to you. Area of a triangle is right there. So this is the base. See the base here? And that's the height. So the area is equal to half 10 by what the heck, right? We don't know the height. So the purpose of this question is to find the height of the triangle. Let's put a right angle there to assist us with that. So we're going to use this triangle here in blue to find the height. See this blue triangle? We're going to use the blue triangle. I'm going to draw it over here. And we're going to talk business. What's the length over here? Tell me the length where this check mark is. Thank you. And if you don't mind, everybody, I'm being lazy in terms of writing the units down. So these are all in meters, so forgive me for not writing meters. What's this guy down here? What's this length here? Good. And there's the height. Okay, let's switch into Pythagorean Theorem mode and get that height. What's the longest side on this triangle? So make sure that the 10 goes by itself. Thank you, people. You're doing great with the chat. Yep. I'll put a little bit extra there, okay? But thank you, Daniel. You're looking really good. 8.6603. So I'm going to go over here. I'll just type it instead of writing it with the stylus because it's way too slow. So the area equals half by 10 times 8.6603. What's the area, people? You get 43.3? Anybody confirm? It says 3 decimal places. No, give H the 3 decimal places. Sorry. Yeah, 43.3. 0. Thank you. Units, what are the units here? Square meters. Thank you, Ram. Thank you, my friends. We are looking pretty good. Since we started a little bit late today, and I appreciate your patience with that, although we are actually going to be ahead of schedule by the end of class today, I am going to just keep on going till about 11 or so, and then we'll see where we go from there. I want to do a question now, and I know I'm not jumping around too much, but I want to do the next question for sure because I promised you this question on the test, okay? This question, a similar question. I don't usually tell people what's on the test. Like I'll tell you how many questions, that kind of stuff. But in this case, I do promise you a question like this on the test. So pay extra attention. That's right. This is called a pipe run. So whoever's done any type of installation of piping, they know that you cannot always get from one point to another point with a straight line because there are obstructions. Like if you're going through a wall or if there's furniture or whatever the heck's going on. Like if you're working behind a sink or something, you won't be able to get that pipe from here to here. You got to kind of use elbows and bends. In this case, the question's asking, what is the total length of this run? So in other words, this plus this plus this. So down at the bottom here, this is my last step, okay? This is my final step. Final step. The length equals 4 feet 9 inches plus something plus 3 feet 10 inches. Let me know if that makes sense to you. Can you confirm in the chat that that makes sense to you? Anybody else? Thank you, Shalon. Anybody else? Let me know in that chat. Tell me that makes sense to you, please. Beautiful. Okay, so what we're going to do now is we're going to get that middle length. Let's call that diagonal length D. So I'm going to call this guy over here, whoops, I'm going to call this thing here D. Just because I feel like it. And I'm going to draw a picture right now. So I'm talking about this. That's D, and there, my friends, is a right angle. So a little bit of a problem here is that we have a mixture of feet and inches. That's not looking too happy. So take this and turn it into inches. So for those people that were doing the assignment 2, you need to do this on assignment 2. So, assignment 3. Someone asked me for assignment 3, can you give us some help? Well, one advice that I have immediately for you is that you make everything inches. So in this case, how many inches is this? How many inches are here? 40 what? Okay. And how many inches are down here? What's 40 4 feet 6 inches? For those that are not clear, thank you. You do 4 times 12 plus 6, so because it's 48 plus 6. So that's 54 inches. So we're going to use inches here. Oh, I'm going to catch up to you, Shalon. You're just steaming by here. Okay, what's the longest side on this green triangle? Let me know what the longest side is on the green triangle. D, thank you. So D squared equals 41 squared plus 54 squared. So D squared, whoops. D squared equals, someone's already typed it there. Is it 2916? Is that correct? Can someone confirm? I think it's more. It seems like it's more. Yeah. I have a feeling it's like, because that's 1600 or so. That's 25, 20. Yeah, it's more. I think it's more. Let's just, thank you, Daniel. Square root that. That's 68 inches, okay? So 68 inches. Convert 68 inches into feet and inches. That's one way to do this. Alternatively, don't touch that. Just put 68 inches here. You'll understand. Thank you, Denny. It is 5 feet 8 inches, but I think you're going to appreciate that it's probably a little bit annoying to add mixtures of feet and inches. So I'm just going to do it this way. This might not be the most economical way, people, but I'll do it this way anyway. So this is 48 plus 9 is 57. Can someone confirm these numbers, please? Can someone confirm those 3 numbers? Thank you. I'm just color coding them, people, so bear with me while I try to be pretty here. Trying to be pretty for you. Okay. So is that correct? I see a thing in the chat there, 171. Can someone confirm Ram's answer? Thank you, Ram. 171, can someone confirm? Okay. Now let's get to, we have to go to feet and inches, so I'll do 171 divided by 12. And it's 14.25. So it's 14 feet and 3 inches. Can someone confirm the final answer? Thank you. Well, there you go, my friends. Well, there's a freebie. There's a freebie for you. So anyway, I just thought I'd put it out there. I have just a mental note for myself that I do want to get to. I do want to get to another few examples of these today. We're not going to do all these questions, and obviously it's impossible to cover every single question here. Although the questions in the book do have answers for you to look for. I can do. Let's do this question here, and then we'll take a break, okay? And that should be good. So take a look at this question here. We have a quarter circle. We have a quarter circle here, and then we have 2 right angle triangles. And the objective is to find the hypotenuse of this triangle down here, x. I'm going to do some labeling, friends, because this is looking pretty crusty. So I'm going to call this triangle number 1. I'm going to call this triangle number 2. And I'm going to ask you for one favor. If this is the diameter Can someone tell me what the radius is? What's the radius? Half of it, yeah. Oh my goodness, look at that. All those numbers are even. Aren't you so happy? They're so even. That means you can just do it in your head, right? You should do it in your head. If they're all even digits, you can definitely divide that by 2 quickly. Anyway, what I want to do now is find a strategy for us to get to this length x. So what I'm going to ask is that we start to name things. When you have compound figures, a compound figure is more than one shape put together. What I want you to imagine is like a jigsaw puzzle. Just imagine a jigsaw puzzle, and it should be entertaining for me to draw this now because I definitely sense a lag on my computer. I think it's because the PowerPoint file is gigantic because I have screenshots. So I'm going to call this here, I'm going to call this A, and then I'm going to call this B. Yeah, exactly, Shalon. First, you want to find something on shape number 1. So this thing here, I'm calling that A, and then this thing here, I'm going to call that B. So let's get A from shape number 1. I am going to speed it up a little bit because I do want to give you a break soon. I shouldn't say figure, I should say triangle. So that's the strategy that we're going to use. So we can just play this out. On triangle number 1, is A the longest side? Is A the longest side on triangle number 1? No. Good. So that means we have A squared plus 5.289 squared equals 8.746 squared. Just checking for something in my notes. Okay, so I'm going to leave that for you to do on your own. You're going to get A is equal to 6.520 inches. So I skipped a little step there, but I am going to do this on occasion just so that I can get you more volume, more quantity of answers. Let's go to triangle number 2. So B is equal to A minus the radius. If you take a look at this picture here, A is all the way to the top, but B is not all the way. You see B, it stops here. So this leftover that I didn't draw, that leftover is the radius. So why don't we give the radius some color? Let's make the radius red. A little bit of alliteration there, I like that. And I'll get my red pen, and that's the radius right there. See, tick, and you can put a little tick there as well, okay? So those are both 2.431. So in this case, B is equal to A. Well, A is equal to 6.520 minus 2.431, which is equal to, what's that equal to? 4.089. Yeah, you do have to have like a real diligent behavior to doing things. But I think that with what I'm trying to do with you with the problem solving is I really want to set a good example for you in terms of breaking the question down into baby steps and simple pictures. So that's really, with these compound figures, you're very welcome. With these figures, it's a really good idea to break these up into pieces like a jigsaw puzzle. And then you can label them separately because a lot of times two sides are given the same, or two connected sides have different names and it gets confusing. Let's go to triangle number 2. So see triangle number 2 here. Triangle number 2 is a little bit weird, but Can you tell me what is the longest side on this triangle? What is the longest side? Yeah, it's x, right? So x squared is going to be by itself, and that's going to equal b squared plus r squared. Now, I didn't really call r anything, so I'm just going to say here, let the radius be r. And then I'll just replace the radius r with r here, so that it's easier to read. Yeah, from here it's easy stuff, absolutely. Because we know what b is, I can just read. It's kind of funny if you guys, if you're wondering why am I pausing so much, it's because I have two different screens and I have my personal notes and I'm reading and the chat. So that's a little bit of a, I'm not used to that many brain cells working on different things at the same time. Okay, so 2.431 squared. So if you don't mind, I'm just going to state the answer for x here. And I got 4.757 inches. Okay, I'm going to turn off the recording now. We will take a short break. So to answer this question number 9, we can use two separate triangles. The first triangle has a height of 18 feet, and then you lower the ladder by 2 feet, so now the new height is 16 feet. Then if we find the base lengths A and B, we can calculate those and subtract the two to determine how far sideways the base of the ladder had to be moved. So we did the first one, and now we're on the second one. On the second triangle, B is not the longest side, so B squared plus 16 squared is 20 squared. And can someone give me some guidance on that? Is it 12? Oh yeah, it's 12, that's right. It's a special triangle. So then the answer, I'll just say here ants for answer, is B minus A, which is 12 minus 8.72, which is how much? 3.28. Can someone confirm? Someone confirm 3.28? Anybody? Thank you, Liban. Sorry, I'm not. I love your participation. I need a second person. It's only one vote per person. Otherwise, we have anarchy. Okay, let's do one more question, everybody, and then I'll give you a preview. I'll give you a preview of next week's class, because as we did that. Oh yeah, and I like this now that you're gonna start to see questions that are not like obvious. So like you get to have a little bit more entertainment. I really want to say that to you, that the stuff that we're doing here, it's so much more animated, so much more like engaging than find the angle. So I need to cover all that geometry with you though, but now we can actually get our hands dirty and do some stuff. Okay, so just read that question for a second while I do some coloring. So this question here involves this curved edge here. Now, the notation here, this thing here, whenever you see that on a diagram, you see this R here, it's referring to a radius. So this is not half a circle, it's not a quarter of a circle, it's not obvious how much of a circle it is, but it is an arc of a circle for sure. So you should be familiar with arc of a circle because we talked about it in the first booklet. An arc of a circle is just a piece of its boundary there, of its circumference, just a piece of it. Could be the whole thing, but for now it's just this little piece. So the question here is to find the length of x here for this very strange looking shape. Now I should mention that the author of these books, they used to do a lot of work in machinery. They were teaching in the machinery and tool and die. And for that reason, in tool and die, as you might know, you get a lot of strange looking cuts and the strange looking figures. So that's what we have here, is very strange looking figure. Anyway, any suggestions on how we solve it? So I wasn't expecting too much there, but it is a weird question. But what I'd like to do is this. I want you to, the 6.5, that's the radius from here to here. That's 6.5. In other words, if you were to draw a circle, there's a big circle. See that big circle? Like that, okay? So this is what I usually do with shapes that have these irregular parts to them. I like to draw a frame around them, like a picture frame. Imagine a picture frame. So our picture frame would go like this. Um, yeah, you could find the length of the arc, Daniel, but you don't need to because it's going to be easier than that. What I want you to imagine is what if I draw a rectangle around this shape? Do you see this rectangle? That's a rectangle, okay? One more thing I'm going to do that's a little bit funny. This is 6.5, the radius, but this line here is actually distracting me. So I'm going to draw it like this. Think of like a piece of pizza. Think of a pizza slice. We don't call that a pizza slice. We call that a sector. So this and this is the radius, okay? So then I'm going to get rid of this arrow here because it's bothering me. And that starts to kind of paint the picture of what to do. So you can frame the figure with the two right angle triangles right here. And then you can use this sector to fill in some of the details. In this question, we're trying to find x. So just for the sake of making it a little bit easier to work with, I'm going to create two more variables for you. So I'm going to call this guy over here in the corner. We need to give it a name. I'm going to call it A. And I'm going to call this length here B. So that's B. That is the worst looking marker there. So let me just straighten it up a bit. Okay. So there, my friends, is our diagram. We're going to do some hypotenuse and some Pythagorean theorems now. So we're going to do the following steps. Find length B. So solve for x, okay? Now, I didn't label the triangles, and it doesn't matter which one is number 1 or number 2. I'm going to call that one number 1 just because I feel like it. I'm going to call this number 2 again just because I feel like it. Because it doesn't matter the order. You can find A first. But this step here, Babubi, you're a champ, eh? So I'm going to go here and I'm going to hook up some skills, okay? Now, this is the last step of the question. And you might say, hey, why are you doing the last step? Because the last step is easy. X plus A equals 4 plus B. And as Mabubi said earlier, yeah, you need to get B here. So let's get that B, and let's get that A, and then let's high-five each other and move on. So from triangle number 1, what is the longest side of that triangle? What is the longest side in this triangle here? That's correct. It's 6.5. So b squared plus 2.7 squared is 6.5 squared. Then, already answered in the chat, I think that's, yeah, I got the same as you, Mabubi. I'm going to put an extra digit if you don't mind. But your answer is beautiful. 5.913 I'm going to put, okay? Nothing bad. I just want to make it a little bit more accurate to help for later. Triangle number 2. Oh, wait a second. Wait a second. I'm kind of cheesed right now. What's this? We don't know the height. Can someone tell me that number? What's that height? Thank you. Yeah. I'm glad you feel that way, Shilan. And thank you for the 5.5. I was joking around. For the 5.5, it's because it's a rectangle. Sorry. I have to label it differently. I'll give it, you know what? It's really special. I'll give it a triple. I'll give it a triple, okay? Triple. There you go. So What's the longest side on triangle number 2? What's the longest side on this triangle down here? Yeah, it's 6.5. Good. Answer for A. Anybody got an A there? I'm going to go for Mabubi again. What's going on? Where are you? Look me up. We got, ooh, I didn't get 12. I got 3. Anybody get 3 point something? Oh, really? Yeah, I think it's 3.464. Thank you, my friend. Yeah, you got to square root that thing. You got to square root that thing. It's dangerous. Don't be forgetting that square root. At this point, I hope that you can add and subtract because I'll be very, very shocked. Shocked. Okay, I got this. I got 6.449. Yep. So remember I said that I would give you a preview of next week's class? I tricked you because this question is a preview of next week's class. This is the preview. Shocking. So what made this question tougher? Tell me in the chat. What made this question tougher? It seems a lot more fun. Okay. What made the question more difficult? Yeah, the figure, right? Why can't autocorrect work with me sometimes? Yeah, the rectangle is my baby. That's my trick. That's my special secret weapon. But this is really what I want to mention here. What made the question difficult or more tricky is finding the right angle triangle. Find the right angle triangle. That's what made it hard, okay? So you might be wondering, am I hopeless? If I can't find that triangle, am I going to like get destroyed now for the rest of this chapter? And the answer is no. I got your back, people. Check it out. I'm going to scroll ahead here quickly and take a look at the title. Take a look at the title of the next section. What does it say? Read the title to yourself. Pythagorean Theorem problems where the triangle is not given. Blessed. That's right, my friend. Now check it up. Check it up. You remember how I told you there's some tricks for the angles and the triangles and the polygons, all those tricks in the first chapter? Well, there's 5 tricks or rules, if you like, that you can use here. Here they are. Here's the 5 rules. These are on page 14 of the notes, so definitely you can dip back and you can do that. I don't think I need Wolfram anymore today, so let's give this some space. What are these tricks? Rule number 1. The center of any circle or arc of a circle is the most important point. In the question that we just did, was the center of the circle important? Yes or no? Let's go back to that figure. Where's that figure? Where are you, buddy? Here's the figure, right? I'm gonna get a nice chunky dot here. Let's use what color do you want? You want to use? Let's use green. Nice chunky dot, okay? This point here is the center of the circle, and indeed, it was important. What's the next thing? If you have an arc of a circle, the endpoints of the arc are important, or may be important. Let's go back to that figure. Oh yeah, look. Here's the arc, and there's the one endpoint, and there's the other endpoint. Yeah, they were important. Okay. There is a symmetry in the problem. Well, we didn't really do that. There was no symmetry in this question. And then questions 4 and 5 involve more complicated things where you have two circles that touch each other. So we haven't really seen any questions where all 5 of these rules hold. But in that first example I did with you, we managed to talk about how we use the arc of a circle and the center of a circle to assist us in solving a question. So there you go. Those are the 5 rules that we're going to explore for, I'd say, 5 or 6 questions at least. And we can start on those questions. We can start by doing questions on next week. But I don't mind doing one more with you today as a good start, a place to stop. And actually, another point to that, Shalon, is that these guys here, if you go back to this figure, this is a neat little comment. The radius of the circle, I can mention it here because it is a very, very valid point. I'll mention it right here. So that's a neat little thing to take away as well. So I'm gonna move on. I really would like to do one more question with you before we wrap things up today. So you'll have to forgive me if I get a little bit what's the word I'm thinking of? A little bit more pushy, a little bit more pushy with you to get through the next question. So let's apply some pressure here, and let's do this one here because it's a good question. So it says here, find the distance x in this figure. Here's x over here. And it says locate some stuff. Basically, do the tricks that we just did. So I'm going to really just magnify this image. And I'll do the trick that we just did together, which was to draw the 2 radii. Here's the center of the circle. So remember the question, one of the rules was to use the center of the circle. So there's the rule here. The center of a circle is important. So we just labeled it. Congratulations. Now, when you have an arc of a circle, the endpoints are typically important. So let's go back to that figure. And I'm not going to scroll back and forth anymore, so don't worry, people. You're good with that, okay? I'm done scrolling. We're going to keep our eyes on the prize here. We're going to stay on this one page only now. So there is a radius. That's a radius, 1.5. And there's another radius. So that's a sector of a circle. And in this case, you can draw a rectangle, but I'm not going to draw a rectangle here because maybe some people don't want to draw a rectangle, and you don't actually need to. The game that you're playing, my friends, the game that you're playing is, and I'll play the game right here, where is the right angle triangle? It was like a game show. Imagine it was a game show, like Millionaire or Deal or No Deal or Game of Games or whatever it is. Where is the right angle triangle? Where's Waldo? Okay, the right angle triangle is right here. It's this little baby thing right here, okay? That's the right angle triangle. So let's talk about some numbers. We need to find x. So I would recommend that you convert decimal fraction inches to decimals. So see how it says 7/8 of an inch here? 7/8 of an inch is 0.875 inches. I'm just going to write that on the side. That just goes without saying. You should make these decimals. And then 3/4 is, of course, 0.75. That should be easy for you. Anyway. Yeah, if you draw the rectangle, it doesn't really help as much here. That's exactly what I'm trying to say. So I'm going to call this from here to here. I need to give that a name. So I'm going to call that A. And I'm going to call this thing from here to here B. So I think that we can get to a place now and solve this. So what I'm going to do is I'm going to find B first. I'll write down my strategy. I do have to let you guys go soon, so I'm going to go a little faster. Find B. I'll stop talking and type a bit, okay? That's my strategy, people. If you forgive me, I'm going to type a lot now. I'm not going to talk as much because I really want to honor that we finish on time so that you can go on to your next meeting. So B is going to equal the following. So we know that 0.75 plus 1.5 plus B plus 0.875 equals 4.36. So what I did there was the following. I said that this plus this plus this plus this equals this. That's what this is saying, okay? Because it's just lengths. So with that in mind, can someone report back to me the value of B? I got 1.235. Please confirm as I move on to the next part. Thank you. Using the triangle. Using this triangle, I can see that the longest side is this purple. This purple is 1.5 inches. That's why it's 1.5. And then A and B are here as the legs of the triangle. We're solving for A. So we know what B is. So A squared plus 1.235 squared equals 1.5 squared. So now that we have that, we can say that A is equal to 0.851. Please someone confirm. Thank you. And then you get that height. I got 1.649. If someone can confirm, then I can dismiss you on time with 20 seconds to spare. Thank you very much, everybody. You were very good with your participation today. Look at what page we're on in the notes. We're on page 18, okay? See it says page 18? You are responsible for everything up to this page. So if anything between page 1 and page 18, if I skipped any questions, because obviously there's homework for you to do, try everything you can up to page 18. And then when we meet on Tuesday, I'll continue from this point onward. And if you want, you can work ahead in the booklet because now you have all the tools. You have all the tools in your toolbox. Have a lovely weekend, everybody. I know you got stuff to do, and I really appreciate the participation. So good work, and take it easy.